All right, the last thing we want to look at here in this kind of initial round of notes is the center of mass frame. This is one in particular that we're going to practice with, and some of the later stuff is going to help you dig deeper into. So for now, just look at the big picture, track with the big ideas. Okay, so the center of mass we want to talk about first. We've talked about this before, but I'm just going to redefine it. The center of mass of a system is the average location of the mass. So for example, if I have M1 here, M2 here, and they're the same mass, the center of mass is halfway in between. If I have M and 2M, then it's going to be, closer to 2M. And this will be 2L, and this will be L, right? It's twice as close to the 2 mass than it is to the 1 mass. Or in other words, it's twice as far from the 1 mass than from the 2. And the reason this is important is center of mass will keep a constant velocity unless acted on by a non-zero net force. So in other words, what we're saying here is with a collision, if you pretend and just look at the center of mass of a collision, you can treat both objects, all the objects involved, as a single system moving with some velocity at the center of mass, and that's going to stay constant. There's lots of places that this is useful. I don't want to give a lot of examples because they're going to take longer to get through than they're worth talking about at the moment. But the basic idea is if I have, two objects and they're coming inwards at each other, then if they're, if they have the same mass and they're moving at the same velocity, but towards each other, well, then the center of mass isn't going to move, right? Because they're always just getting closer, and they hit and they rebound out. The center of mass stays constant. The main place that this comes up in the AP test is like, I don't want to say trick questions, but like questions where what they're really looking for is, do you recognize whether there's external forces acting on the system or not? So here's an example. Two objects of the same mass travel in the direction on the horizontal surface. Object X has a mass of 5, or has a speed of 5. Object Y has a speed of 2. At some point, they collide and they bounce off. Which of the following predictions is true about the center of mass? And it is that the velocity of the center of mass does not change. So the objects collide, the objects will change how they move. One might speed up, one might slow down. But if they collide, they're going to keep moving. The center of mass is going to keep moving. This is useful for if they stick together, because if they stick together, it's still B. But what this means is if we know how the center of mass is moving before the collision, and we know that they're going to stick together, by definition, they have to move off with the same speed as the center of mass is moving before the collision. This is one of those instances where it kind of starts to get useful to consider center of mass. It also, if you remember the problem that we've done before of like a person is standing on a raft and they start walking, well, in that case, the center of mass has to remain in the same place because there's no external forces. So you can just kind of look at the different pictures and figure out which of these pictures has the center of mass not moving. This is kind of the idea that we want to start planting in your head is, yeah, there might be complex stuff going on inside of the system, but the system itself, if there's nothing pushing or pulling the system, like the collection of objects, the system itself has to move with a constant velocity. So that'll wrap up kind of our introductory notes. We'll do a lot of practice with this, look at kind of specific examples, get experience with it, and that'll help you put all of this into practice.